Welcome back to Building Trust with Built Environments. We are here for our final day of fire testing at the ICC NTA lab in Bryan, Texas. So far, we've learned the importance of fire testing and witnessed the NFPA 285 test in action. Today, we'll be meeting with our partners to discuss our final fire test, which is for the ASTM E119 test. Let's kick things off with Jarrett Davis, Principal Building Scientist with Built Environments. All right, Jarrett, you and your team have done a great job preparing our client's product to be tested. Final preparations are underway, but before things get started, tell us what's the reason for this test relative to the product?
Yeah, thanks, Bree. This is a fire test for ASTM E119, which is a standard which essentially tests how long it takes for fire to break through a wall assembly. In this case, our client's a new supplier of magnesium oxide panels for primarily commercial construction. This uses metal or steel studs, in which case the fire resistance is of critical importance in wall assemblies. To enter into the market, their product needs to pass these fire tests to garner the approvals needed for architects and project teams to specify it on their jobs. In this case, we're testing 2 layers of 1/2-inch exterior wall panel to see if it can earn a 2-hour fire rating on the steel stud.
Okay, so that's really an important step for companies in our industry when launching a new product. And this process helps them prove their fire resistance and in turn, build trust with their clients. That also makes sense as to why it is such a robust test. If this product passes, what's next for it?
Well, like other clients and products that we've worked with before, all of our work is to help them pass this test so that they can enter into an existing market, or in some cases, create entirely new markets. For this one, this product will enter a rapidly growing market of MGO products, which we've spoken about before, enabling it to be used in all building types, metal or wood studs. This is a crucial step in that process.
Oh yeah, a very important step to join the competitive market. Thanks for explaining that to me, Jarrett. Next, I'm going to introduce you to one of our clients whose wall we're burning up next. All right, I'm here with Ryan Miller, General Manager of USMGO Company, which is one of the 2 client companies we're testing this week. So Ryan, you have a new company and a new product, and you're about to set it on fire. Why?
That's right, Bree. It's a big week for us. Launching a new product and a new company, it takes a lot of steps and a lot of partners that you need to be able to do it with. Our new product, Innovation MGO, has a lot of benefits, and the primary one is fire resistance. That makes it applicable to all building types, which is really important for us. So marketing claims are one thing, but reporting how your product performs when it's actually set on fire, that's something else, and that's what we're here to do today. And as this product is designed and installed for life safety, ensuring that it passes the necessary code requirements, well, that's critical.
Exactly. And that's what we're here to do. So what has the process been like to prepare for this big week?
Well, fortunately, we have a great relationship with your team at Built Environments, and they've guided us through the process really from concept to where we are today, which is being here to do this testing. So I cannot imagine going through this process, though, without the help of your experts, which have helped us design the test plans. They've helped us get the logistics to put this thing together and then actually be here with us nice and early to get this testing started. Afterward, this process will work with your team as well to publish those reports. We will get all that information online, and then that's going to position us to succeed in the market. So Built Environment's help has been invaluable in helping us to launch Innovation MGO.
Oh, well, I'm so glad to hear that. Thank you for sharing with us, and good luck on that test. We will all be watching. All right, I think we're ready to get this thing fired up. Should we do it?
Let's do it, Bree. Let's run our E119. Let's see what happens. But first, let's make sure we get to our safety positions.
Yeah, I'll be gone. For the ASTM E119 test, our team has constructed a 10-foot by 10-foot wall using USMGO's Innovation wall panels on steel studs, along with other assembly elements including gypsum. The furnace must be calibrated to replicate the standard fire curve outlined in the test standard, starting at ambient temperature and increasing to approximately 1700 degrees Fahrenheit. It will then maintain that temperature for 120 minutes while our team closely monitors the wall and its structural integrity. Then the test wall is removed from the furnace. The technicians then spray the wall with a fireman's hose at 30 psi for a little over 2 minutes in a specific grid pattern. We'll be looking for any significant deflection, structural collapse, or failure to hold the load, as well as excessive heat transfer to the unexposed side of the wall, which we will measure using thermocouples spaced on surfaces and strategically throughout the wall assembly. That was incredible to watch. I have never seen anything like that, and the wall is still standing, so that must be a good sign. So did the test perform how you expected?
Yeah, Bree, it actually did a little bit better than we expected. We were expecting to have to do another wall for the hose stream test, but this wall actually survived all 2 hours and the hose stream test. So it actually did really, really well, and the deflection wasn't nearly as much as what we expected it to be.
That's awesome. Plan for the worst, get the best results.
Right.
I love it. What were you concerned about during this test?
Yeah, that's a great question. During the test, it's always a little bit of a heartbeat affair. We started to see a little bit of deflection in the middle of that wall, and that's where we start to see the studs, especially in steel studs, they get a little bit of warm. And as they get warm, they have a hard time holding that load because this was a load-bearing wall. So we were interested to see how much it was going to deflect, and we kind of got close to that limit, but we never got there. So we decided to proceed at that load limit all the way through the test, and it ended up being successful.
Great. So did anything technically go wrong during this test, or were these ideal results?
No, actually, we had no issues. Nothing really went wrong, and you can see behind us, the studs actually still look really good. Actually better than we expected even before we started dismantling the wall. So our temperature curve was great. The load was great, and everything worked out really, really well.
Great. I'm sure we can accredit that to all of the planning and details and months you guys have spent, and Mike's expertise and everybody else.
Yeah, this was a full team effort with Priested Associates, ourselves, ICC NTA in the lab. This was a very successful test that helped us get a great result.
All right, we came, we saw, we burned, and we passed. Thank you so much, Jarrett, for taking us here and showing us this incredible test.
My pleasure.
Well, I hope you all enjoyed this exciting trip to the ICC NTA facility here in Bryan, Texas. A big thanks to the team here for allowing us to see the up-close and detailed look into building and material science and just how strenuous these tests have to be. I know I feel a lot safer knowing this kind of in-depth testing is going on before products hit the market. Thanks for tuning in, and if you have any specific technical questions about this test or want to know how you can get scientific testing done on your own product, send them in to our team at Built Environments, and I'll make sure they get answered by one of our building and material scientists.